This video is going to focus on taking your understanding of ratio and representing it into an equation, and then working in reverse and taking an equation and using it to set up a ratio table that satisfies that equation. So let's take this statement here. Jasmine made a blanket using orange and green yarn in a ratio of 3 inches to 1 inch. So for her blanket, for every 3 inches of orange yarn, she used 1 inch of green yarn. So normally we just take this and we represent it. Orange to green would be 3 inches to 1 inch of green. And we're used to working vertically in our tables to get to some target. So we could continue to work down if we wanted, and we would know, okay, it's 6 to 2. For this, however, in this lesson, we're going to focus, instead of going up and down in our table, we're going to focus on that relationship going across between orange and green. And there's a lot of statements that we can make here. So you can see that going from orange to green, orange is, we would say 3 to 1, but we don't need to represent that denominator. So we could say orange is 3 times green. We could say something else like green is, it would be a 1 to 3 ratio from, and we can represent that by saying green is 1/3 orange. We could also continue if we wanted to, and other things we've worked on is saying like green is 1 to 4, or 1/4 the total, whereas orange would be 3/4 the total. This is basically the foundation of transitioning into an equation. So when you write equations, equations now have equal signs. So you're thinking, if we know what orange is, how can we use that information to find green? Or if we know what green is, how can we use that information to find orange? So one of the most simple ways is to start looking at orange. What does orange equal? Well, there's a relationship that we just wrote out between orange and green. Orange is whatever green is times 3, and we can represent that by saying 3g. And if you see a number in a variable like this, that means times. So orange is 3 times g, or orange equals 3g. The way to use an equation, whatever number you input for green, you would multiply that by 3 in order to find orange. We could also work in reverse by saying green is orange divided by 3, or 1/3 orange, which means orange divided by 3. And I'm going to put in parentheses orange divided by 3. 1/3 is the same as saying O divided by 3. So green equals 1/3 orange. We could also extend this relationship, and these are the 4 different types of equations. When I ask on something like homework, represent this relationship with 4 equations, we're not going to focus as much on the table, because on the total, I want to focus on these part-to-part relationships. We could also do, if we look at going across, we could say O divided by G. Not sure what's happening with the pen. O divided by G, or orange yarn divided by green yarn, equals 3. And we could work in reverse too. Green yarn divided by orange yarn equals 1/3. If we know our parts. So those are other ways to write the equation. Now, in the second part, when we go to you're given an equation and you need to complete a ratio table, just be aware that I could represent this information a lot of different ways. Instead of saying whatever G is times 3, I could have written orange equals, let me just put a slash here, orange equals 300% of G. And 300% would be like times 3. So whatever G is, that would be 100%. Orange would be 300% of that. 100% times 3. So 3 times G, the same thing. I could also represent this in a lot of different ways as well. I could, of course, say G equals 1/3 of O, because in that 1-to-3 ratio, or O divided by 3. I could also say green equals, we could find out what is this 1/3 as a decimal. And to find 1/3 as a decimal, remember, to get from a fraction to a decimal, I'm going to do it at the bottom over here. To get from a fraction to a decimal, we want to get rid of that denominator and make it 1. Because a number divided by 1, then we don't need to represent that. So we're dividing by 3 to get rid of that. 1 divided by 3. 3 goes into 10 3 times, and you'll notice we'd have 1 remaining, and we'll just keep repeating. So it's like 0.33. So G equals 0.33 of orange. We could have represented it like that. And these are O's. I realize that kind of looks like a 0, but that's orange. Or we could have represented it as a percent. By thinking as a percent, we want that denominator to be out of 100. And we'd be multiplying by like 33.333. So we could have said G equals 33.3% of O. And these are all these different ways to just represent this same piece of information. So keep in mind, and this is where we talk about having mind flexibility, all of these mean the same thing. You will also get questions that ask something like, what is, let me just pull this up a little bit. What is the value, I'm going to just pull this down, what is the value of the ratio of the amount of green yarn to the amount of blue yarn? The question seems confusing, but it's pretty simple. You're just looking at the value of the ratio between green, and I realize that says blue, that should say orange. So green to orange, what is the value of the ratio amount of green yarn to orange? It would be 1 to 3, and we would represent that as 1/3, and that's the value. So if you see a question like that, don't be confused. That's all it's asking. For the next part, now you need to construct a ratio table that satisfies these different equations. So A is 3/5 of B. This can kind of be confusing, but if you remember, fractions are ratios. So what this is saying is A to B is in a ratio of 3 to 5. Because remember, we could simply go from 3 to 5 and express that as 3/5. So all it's saying is A to B is in a relationship of 3 to 5. And once you find that first part, the only difficult thing is to get that first value in your ratio table. Then it will be simple to get that second value and the third value. Another way of thinking this is if you get stuck, I always say, think about it if it's 1. So if you didn't know to start at that 3 to 5, make one of them 1. What happens to the other? And we could think about A equals 3/5 of B. And if we think about it in a fraction model, and this is B, the whole thing is B. And let's just say B equals 1. What is 3/5 of 1? Well, we're taking 1 and dividing it into 5 parts. And we'd be taking 3 of those 5 parts. 1 divided by 5, each of these would be 1/5. And if we took 3 of them, it would be 3/5. So if B was 1, A would be 3/5. And that's what that means. That it'd be at a 3 to 5 ratio as well. But the simplest part to start would be recognizing 3/5 means 3 to 5 ratio. For the second part, A divided by B equals 0.25. If you're thinking in terms of brain flexibility, you might realize, hey, 0.25 is like 1/4. So I could just do the same thing again. And that would be to your advantage to be able to recognize decimals are also fractions, and if that's simpler, well, you can just get right into that 1 to 4 ratio. Or A divided by B is 1/4, 1 to 4. You won't always see it that way, though, and know what it is so quickly as a fraction. So to think about it, we have A divided by B equals 1.25. Use 1. 1 is very powerful because any number divided by 1 will be itself. So if we wanted to say if A is 0.25, let's just say 0.25 divided by 1 would equal 0.25. Knowing that any number divided by 1 is itself. So use that information to set it up. And we could start right here, 0.25 to 1. Any number divided by 1 is itself. So that would be a way to get that first piece of information into your table. Also, if you got it to the fraction, you would have realized that's 1/4. So that would also be 1 divided by 4, which is the same thing as 0.25 to 1. Both of them are 4 times. For the last one, A equals 150% of B. So what this is saying is whatever B is, A is going to be 100% of that, and then even 50% more. It's going to be 150%, so A will be bigger than B. If you think about this, we talk about percents relating to meter stick. If B was, let's say, 100 centimeters, a whole meter stick, and I said A is 150 of that, A would be 150 centimeters. So a simple way to get this is thinking if B is I wrote it in the wrong spot there. If B is 100, and we're thinking like 100 centimeters, because percent is per 100, A would be 150 of that 100. That's what it means. Use your understanding of percents. Percents are per 100, so it's 150 per 100. Now, you could also get that by plugging in any other number and using kind of your understanding of 1. So if we made B 1, A would be 150% of that. So if I'm thinking percent and number, 100% of the number would be 1. 50% would be half of that, which would be 0.5. And 150 would be 100% plus 50%, or 1.5. So 1.5, but that's also the same thing as 150 to 100. So the only challenge with that second part is just figuring out what's the first value to getting your ratio table. And once you figure out that, the rest will be pretty simple.